going over the study guide for Chapter 4 for the geometry test. Again, what we're going to do is fill in the entire picture, and then after we filled in the entire picture, we'll answer the questions. The first picture is a parallelogram. I call it a whampa-jawed rectangle. Uh, anyway, it's of the form of a rectangle that's been knocked over kind of sideways or crooked. So we're going to go through the properties of all parallelograms. A parallelogram is a quadrilateral having both pairs of opposite sides parallel. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Knowing that those are parallel, then we know that alternate interior angles are equal. So this angle right here is alternate interior to this one, so it's 30. This angle up here is alternate interior to this, and so it's 40. The sum of the angles of a triangle is 180, so we could add those two up. 140 plus 30 is 70. 180 minus 70 is 110, so this angle is 110, and the one vertical from it is 110. Again, a straight line's 180, so if we could take this straight angle, which is 180, minus the 110, we'll get this angle being 70, and the one vertical to it is 70. If this angle right here is 75, then this angle over here is 75 because they're alternate interior. The sum of the angles of a triangle is 180. So if we add the 70 here to the 75, we get 145, and 180 minus 145 is 35, so this would be 35 degrees. And the one alternate interior to it, which is this one, is 35 degrees. So we got all the angle measures. Let's go ahead and answer all the questions about angle measure, and then we'll deal with the length of the sides. So by definition of a parallelogram, both pairs of opposite sides are parallel. And since they're parallel, then alternate interior angles are equal. It's always true that vertical angles are equal. It's always true that the sum of the angles of a triangle is 180. It's always true that a straight angle is 180. So we're using that information to answer all the questions about the angles. So angle ACD, I'll do it in blue here. Remember, you go from A to C to D. Angle ACD is 40 degrees. Angle ACB is 75 degrees. Angle ADC, I'll color it in. ADC is from A to D to C. So it's a whole angle at D. So we have to add up the 30 and the 35 there, you can see, which together would be 65. Angle BCD would be this entire angle over here, which is a 75 and a 40 put together, 115. Angle BEC, E's in the middle, so BEC goes from B to E, the middle, to C. You can see that's that 70 degree angle. And then we're back to a segment. So I'm going to take all of the angles out of there, and we'll focus on the segments now. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. We did all of that angle stuff from that. And then we know that both pairs of opposite sides are equal. So if this side is 8, its opposite side is 8. And if this side is 13, then its opposite side is 13. We also know that the diagonals bisect each other. So point E is the midpoint of both diagonals. So if this half of the diagonal BD is 10, then the other half of diagonal BD is 10. Therefore, the entire diagonal BD is 20. If this half of diagonal AC is 4, then the other half of diagonal AC is 4, making the entire diagonal AC 8. So AD is 8 because opposite sides of a parallelogram are equal. DB is 20 because the diagonals bisect each other. If this half is 10, then this half is 10, so the whole diagonal BD is 20. AB is 13 because opposite sides of a parallelogram are equal. AE is 4 because the diagonals bisect each other, and if this half of that diagonal is 4, then that half of that diagonal must be 4 also. Any questions on the parallelogram? Now, as we go down the page, you will find that I give you less information. I give you less information as far as the angle measures and side lengths being marked, because we're going from a parallelogram to a rectangle to a rhombus to a square. And as we move up the ladder here, these things have more properties. The more properties they have, the less information I have to give you. And so you need to know the properties of all of these from memory and then be able to apply them in a picture. So let's review for a parallelogram. In a parallelogram, the definition says it's a quadrilateral having both pairs of opposite sides parallel. Parallelograms have 6 properties. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. Now, a rectangle is a special type of parallelogram. So it contains those 6 properties plus its definition plus one more property, giving it 8 total properties. The definition of a rectangle is it's a quadrilateral with 4 right angles. It's a quadrilateral with 4 right angles. And so we know that all 4 angles are 90 degrees. Now, we also know that a quadrilateral is a parallelogram, which means that both pairs of opposite sides are parallel. We'll go through all 6 properties. Both pairs of opposite sides are equal, so if this side is 4, then the side on the left is 4. If the top is 11, then the bottom is 11. Both pairs of opposite sides are parallel. Both pairs of opposite angles are equal. Opposite sides are equal. Both pairs of opposite angles are equal. We can already see that, 90 and 90 and 90 and 90. Consecutive angles are supplementary. We can see that, 90 plus 90 would be 180. That's these same sides make a C, and they're supplementary. Or consecutive angles of a parallelogram are supplementary, which we can see those at up to 90 that way. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. But the other extra property of a rectangle, besides its definition, which says you get 4 right angles, is that the diagonals are equal. Notice in the parallelogram above that we have a long diagonal in the way that it's been not clumpy jawed, and a shorter diagonal the other direction. Now, if it wasn't not clumpy jawed, then the 2 diagonals would be the same length. Now, if they're the same length to start with, and they bisect each other, then that means J is the midpoint of both, and if they were equal to start with, then all 4 pieces inside there are the same length, which was not true on the parallelogram. We had a 10 and a 10, so this one was 20, and a 4 and a 4, and so that one was 8 altogether. If this little piece in here is 6, then all of those little pieces are 6, which makes this a set of 4 isosceles triangles. And if those are isosceles triangles, then we can say that this angle is the same as this one over here. Base angles of an isosceles triangle are equal, or angles opposite equal sides are equal. Now this one's 30 because this one to the upper left is 30, alternate interior angles are equal. And this is 30 because we're back to an isosceles triangle. The sum of the angles of a triangle is 180 degrees, so 30 plus 30 is 60, and 180 minus 60 is 120, so these 2 vertical angles are 120. A straight angle is 180, so if we take 180 minus 120, we get 60 for these two. We know that this whole corner is 90. Each angle of a rectangle is 90 by definition. So if we take 90 minus that 30, we're going to get 60 here and 60 here. Now you can see that that creates a problem. This is a messed up problem, and that's good that I videotaped it. There's no way that this can be 6, and this can be 6, and this can be 4 if all of the angles are 60, because we know if we have a triangle where all the angles are equal, we call it equiangular. If it's equiangular, it's also equilateral, which means all the sides need to be the same. So we need to scratch out the fact that that's 4 and make it 6, and we can make this 6. Now that probably doesn't work either if we go through the Pythagorean theorem, because this square plus this square should be equal to a squared plus b squared equals c squared. But we'll just kind of leave that. We'll try to do a little bit better job on the test. There's some things that we don't know yet that as we deal with them now, we'll just have you work through and assume you don't know those things, and so you're just manipulating what you do know. We won't worry about it, but you should know that if each angle of a triangle is the same, then the sides opposite those equal angles are equal. And so that should have been 6, 6, and 6 there, or 4, 4, and 4, but you can't have different lengths, okay? Okay, so let's answer some questions. Fi was 4, but we're going to change it to a 6 so that we have that equilateral triangle situation on the left and the right. Fj, J is the center. Fj is 6 because all 4 diagonal pieces are equal since they were equal and bisect each other. Ig is a whole diagonal, which is 2 6s, which is 12. IH is the bottom, which is 11. Angle GIH, GIH is this angle down here, which was 30 degrees. Angle IFJ is this angle right here, which is 60 degrees. Angle FGI, FGI is this angle up here. It's 30 degrees. Angle FIJ, FIJ is this angle right here. It's 60 degrees. Angle FJG, FJG is this angle right here. It's 120 degrees. So, a rectangle has 3 special properties. Its definition, which says each angle is 90 degrees, and the fact that the diagonals are equal to begin with, which really it's got 2 special properties, but then because of the fact that we know those diagonals are equal and bisect each other, we get another concept built into the rectangles, which is a bunch of isosceles triangles. And so then we have, if 2 angles of a triangle equal, then the sides opposite those equal angles are equal. 2 sides of a triangle are equal, then the angles opposite those equal sides are equal. So we got all that isosceles triangle stuff going on. Any questions on 10 through 18? Okay. Again, these pictures are not drawn to scale, and so sometimes using the information given at this stage in the game, I'll refer us back to this. These all came out to be 60, which means that should have been equilateral, which it doesn't even look like it. If this is 6 and this is 6 and this is 6, this would have had to have been 6, and I had a 4 there. And so we really needed that to be a 6 so that we actually have an equilateral triangle, even though that doesn't appear to be equilateral. So Anyway, number 19 through 27, we have a rhombus. And a rhombus, by definition, is a quadrilateral with 4 equal sides. It has other special properties, and those special properties are that the diagonals bisect each other, which makes all those angles 90, and each diagonal bisects a pair of opposite angles. So this diagonal bisected that angle, so we've got a 40 adjacent to a 40. We know that opposite sides of a parallelogram are equal, so that's going to make these two be 40 also. Remember, in a rectangle, you had 4 equal angles, but they weren't adjacent to each other. See where those 4 equal angles are located versus where they're located on a rhombus? Now we know that the sum of the angles of a triangle is 180, or we know that the acute angles of a right triangle are complementary. So if we've got a 40 and a 90, the other one's 50. By, again, either the sum of the angles of a triangle is 180, or by the acute angles of a right triangle are complementary. We know that all 4 sides are equal, so if this is 5, this is 5, this is 5, and this is 5, we begin by knowing that that side KN was 5. So let's answer what we can, knowing what we've said so far. KM is that whole diagonal. We haven't talked about that. Let's get the angles. Angle KOL. O is the center. KOL is 90 because the diagonals of a rhombus are perpendicular. Angle OLM is 40 degrees because each diagonal bisects a pair of opposite angles. Angle KNM, KNM is this whole big angle. Opposite angles of a parallelogram are equal, so if this is 40 plus 40, which is 80, then the opposite angle, the angle opposite it, would be 80 also. 40 plus 40, which is 80. Opposite angles of a parallelogram are equal. A rhombus is a parallelogram. Number 26, angle LMN from the sum of the angles of a triangle is 180, or the acute angles of a right triangle are complementary. We got that that angle was 50 degrees. Angle LKO, LKO is 50 for the same reason. Now, what we've not answered is the sides. We'll take a look at that. We still know in a rhombus that the diagonals bisect each other. So if this is 3, that's 3. And if this is 4, then this is 4. And we did do a good job here because that's 90, and this would have to be 3, 4, 5 to create the Pythagorean triplets, 3, 4, 5. Occasionally in the front of the book, when we've not gotten to something at the back, I may not try to satisfy all the rules you haven't learned yet as I create these problems. I probably should have, but that was pretty obvious on the rectangle that that should have been an equilateral, so we made an adjustment there. Okay, let's answer the questions in about the sides. We knew that the diagonals bisect each other, so that's true, and the sides are all equal on a rhombus, so all of these are 5s is true. So KM, the diagonal, if 1/2 is 6, if 1/2 is 3, then the whole thing is 6. LO, if 1/2 is 4, the other half is 4. LM, the sides of a rhombus are equal, so if one side's 5, they're all 5. OM is 3 because the diagonals bisect each other. Any questions on the rhombus? Now, a square is a quadrilateral with 4 equal sides and 4 right angles. The fact that it has 4 equal sides makes it a rhombus, and it makes all these 4 square root of 2. It's also a rectangle because the other part of its definition says it has 4 right angles. So a square is a quadrilateral with 4 equal sides and 4 right angles. The 4 right angles makes it a rectangle, which means the diagonals are equal and bisect each other, which means you have 4 little equal diagonal pieces. So if this little diagonal piece is 4, then all little diagonal pieces are 4, which creates a bunch of isosceles triangles. All 4 sides are equal, which means that it's also a rhombus. A square is a rhombus, and we know that the diagonals of a rhombus are perpendicular, so all those are 90. We also know that each diagonal bisects a pair of opposite angles. Now, if the diagonal bisects this angle, which was 90, then both little pieces will be 45. Same here, and same here. And so now we filled in the whole picture just using our properties. SR, R is the bottom, SR is the bottom, is 4 square root 2. PS is the left side, it's also 4 square root 2. SQ, the whole diagonal from bottom left to top right, is 4 plus 4, which is 8. ST, which is half of a diagonal, is 4. Angle RQP, RQP is an angle of the square, and each angle of a square is 90 by definition. Angle PSQ is half of an angle. Each diagonal bisects a pair of opposite angles in a rhombus, and a square is a rhombus, so that's 45 degrees. Angle PTQ is this angle right here. The diagonals are perpendicular because the square is a rhombus, so that's 90 degrees. Angle PQR is this angle of the square, and by definition, each angle of a square is 90. Angle SPR, SPR is this little angle right here, which is half of one of the angles. Each angle's 90, so half of that's 45. Any questions on the parallelogram, rectangle, rhombus, or square? Again, my suggestion is to say the properties in your head. You should have them memorized and understood. And then as you say the properties, and using the fact that the sum of the angles of a triangle is 180 and a straight angle is 180, you should be able to fill in the picture. Also, knowing that opposite sides are parallel, we know then we could use that same side interior angles are supplementary. We could use alternate interior angles are equal, and any of those other theorems relating to parallel lines. Okay? The next says what allows us to conclude that the following are parallelograms. If we can't reach a conclusion, we'll put no conclusion. Now, remember how to prove that a quadrilateral is a parallelogram. Number one, both pairs of opposite sides are parallel. Of a parallelogram. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. Consecutive angles are supplementary, or the diagonals bisect each other, or we don't use consecutive angles are supplementary because you'd have to prove all 4 sets. By then you've already proved it by something else. That's a property, but not a way we prove it. So both pairs of opposite sides are parallel, both pairs of opposite sides are equal, both pairs of opposite angles are equal, the diagonals bisect each other, and then one that's kind of a mixture of two properties, but it's not two full properties, and but it's a way to prove it, is that one pair of opposite sides is both equal and parallel. Now, number 37, we've got a pair of opposite sides that are equal, which isn't enough to prove it in and of itself, but it does show us that this angle is equal to this one. Now, these are alternate interior angles are equal. If alternate interior angles are equal, then the lines that form them are parallel, so that tells me that the top is parallel to the bottom. That now gives me one pair of opposite sides, both equal and parallel, so we can say that it is a parallelogram because one pair, I'm going to abbreviate, of opposite sides is both equal and parallel. One pair of opposite sides is both equal and parallel. Number 38, knowing that this angle is equal to this one, and those being alternate interior, we reach the conclusion that the top is parallel to the bottom. These two angles being equal, and those being alternate interior angles, prove that the left is parallel to the right. So what we have is both pairs of opposite sides parallel, which is the definition of a parallelogram. And so we prove that that is a parallelogram by definition of a parallelogram. Here we have a 4 and a 4, and so this must be the midpoint, that the one diagonal bisected that one. This is 3 and 3, so this diagonal got bisected also. The diagonals bisect each other, which proves it is a parallelogram. Any questions on 37, 38, 39? So ways to prove a quadrilateral is a parallelogram: if both pairs of opposite sides are parallel, if both pairs of opposite sides are equal, if both pairs of opposite angles are equal, if the diagonals bisect each other, or if one pair of opposite sides is both equal and parallel. And then we come to a series of theorems. The first one here, number 40, says if three parallel lines, we know they're parallel because of the arrow. If three parallel lines divide one transversal into two equal pieces, then they must divide every transversal that passes through there into equal pieces also, so x equal 2. Now, number 41, we're talking about a theorem that says if a segment joins the midpoint of one side of a triangle and is parallel to a second side, then it must hit the midpoint of the third side. It's evident to us that B is the midpoint of AC because of the 1 mark, and so we already know that point B is a midpoint. We would like to know if point D or F is a midpoint. And so let's just put D as our question. Is D a midpoint? Well, let's see. If this segment, that's a segment containing D, we're going to say the theorem. If a segment hits the midpoint of one side of a triangle, and that same segment is parallel to the second side, then we could reach the conclusion that it hits the midpoint of the third side. To reach that conclusion, then, we would have to know that the segment BD is parallel to segment AE. Well, we have that this angle is equal to this one. Those are alternate interior angles, and so we can conclude that BD is parallel to AE. So now we can say that D is a midpoint, because if a segment hits the midpoint of one side of a triangle and that same segment is parallel to the second side, then that segment must hit the midpoint of the third side, and so we know that point D is a midpoint. Well, now we're wondering about point F. Does point F hit the midpoint of one side? Yes, it hits the midpoint here. We just proved that. If we knew that it was parallel to the second side, then we could say that F is the midpoint of the third side, AE. We have no way of proving that these are parallel. Therefore, we have no way of proving that F is a midpoint, and so we're stuck with only being able to conclude that point B and point D are midpoints. Any questions on that? Okay. If you're wondering why there's not any questions, when I videotaped the algebra, I'd say, are there any questions? And there were times there would be questions because I videotaped it live. When I'm videotaping the geometry, there's no students here. I'm videotaping with an empty classroom, but I still ask to give you time to think personally. Uh, if you have questions and wondering why nobody else did, it's because there's nobody there to ask questions. I'm giving some time there just for you to think and pause and to think about it. If you do have questions, it would be time to rewind and watch again. All right, number 42, we're looking for some angle measures, and then we're going to be looking for our length of a side. This brings us to the next theorem, which says a segment that joins the midpoint of two sides of a triangle. That's how it starts. And so we have the beginning of that theorem. A segment that joins the midpoint of two sides of a triangle is, now here's the conclusion, parallel to the third side, and its length is half the length of the third side. If a segment joins the midpoint of two sides, then that segment must be parallel to the third side, and its length must be 1/2 the length of the third side. Half of 12.62 is 6.31. If these are parallel lines, which they are because it fit that theorem, then corresponding angles are equal. Corresponding angles make the letter F upside down there. And so we've got two sets of corresponding angles, and we can't see that one. That one was 70. So if this angle up here is 60, then this one is 60. And if this one down here is 70, this one is 70 because corresponding angles are equal. The sum of the angles of a triangle is 180. So if you add the 60 and 70, you get 130, and 180 minus 130 leaves 50 for the last angle there. So angle IGK is 70 degrees because it is 60 degrees because it's corresponding to that given 60. Angle GIK is this angle up here. It's 50 because the sum of the angles of a triangle is 180. Angle IGK, that's the same as that. It's still 60. Angle, our segment HJ, it was half of the third side, so it's half of 1262, which is 631. Again, if a segment joins the midpoint of two sides of a triangle, If a segment joins the midpoint of two sides of a triangle, then that segment must be parallel to the third side, and its length is going to be half the length of the third side. Any questions on that? Okay. Number 46 brings us to a theorem that says the midpoint of the hypotenuse of a right triangle, the hypotenuse is the side across from the right angle. The midpoint of the hypotenuse of a right triangle is equidistant from the vertices of the triangle. So from that midpoint to this vertice, from the midpoint to this vertice, and from the midpoint to this vertice is all the same. So if this is 6, this is 6, and this is 6. So LN is 6. Any questions on number 46? Number 47 through 50, now we have a trapezoid. A trapezoid is not a parallelogram. A parallelogram is not a trapezoid. A parallelogram has both pairs of opposite sides parallel. A trapezoid has exactly one pair of opposite sides parallel. The opposite sides that are parallel are called the bases. We might say it has an upper base and a lower base, or base 1, base 2. If it was setting sideways, then it would be a left base and a right base. So you really may not want to say upper base, lower base, because it may not be setting that way. And so it does have two bases. The bases are the parallel sides. The legs are the other two sides, the non-parallel sides. The segment that joins the midpoint, the segment that joins the midpoints of the two legs is called the median. So, a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. The opposite sides that are parallel are called the bases. So the bases are side AB and side ED. The legs are side AE and side BD. And the median is the segment that joins the midpoints of the legs. We know that the median has two properties. Number one, the median is parallel to both bases. And number two, the length of the median is equal to 1/2 the sum of the lengths of the bases. Or we could say that the length of the median is the average of the lengths of the bases. Using that formula, if FC, if the median is 8, then we can say 8 is 1/2 of base 1 plus base 2. So what would AB plus ED have to be? In other words, what would the sum of the bases have to be for that to be an 8? In other words, half of what is 8? Well, half of 16 is 8. So if the median is 8, then the sum of the bases is 16, because the median is half the sum of the bases. If these are all parallel, then we have corresponding angles are equal here. So if that's 110, then this is 110. A straight line's 180 or a straight angle's 180, so that's 80, and this is 80. So once we know they're parallel, we know that same side interior angles are supplementary. We know that corresponding angles are equal. We always know that a straight line's 180. So AED is 80 degrees. You can see how we worked our way there. Any questions on the trapezoid? Okay. Number 51, we have a proof where we're doing the entire proof. I'm going to kind of clean up just a little bit here with my little whiteout thing. Sorry, we are on number 51. I'm just going to kind of take some of that out, just to be able to focus here. I'm going to get this line out. Okay. Remember, to do a proof, we're going to write the given proof, put the statements on the left, reasons on the right, draw the diagram. The proof is the statements and reasons. Below the diagram, we're going to create a note section. We'll begin the proof. Remember, we said when we do a proof, we're going to take what we're given. We're going to mark it in the diagram. We're going to write statements and reasons derived from the markings in the note section. If we mark exactly what it said in the given, then the reason for that will be given. We'll think, is there anything else that I can conclude from being given that just jumps out at me? No, so we go to the next given statement. It says that angle A is equal to angle D, so we mark that. Angle A is equal to angle D. We're going to write down that angle A is equal to angle D. We marked exactly what it said in the given, so it's given. We think, is there anything we can automatically conclude now? Say, well, yes, because we see that we have both pairs of opposite angles are equal. And if we know that both pairs of opposite angles are equal, we could say that A, B, C, D is a parallelogram because both pairs of opposite angles are equal. So the information they gave us was enough information to reach the conclusion it's a parallelogram. Now we know that if it's a parallelogram, it has 6 properties. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. The diagonals bisect each other, and each diagonal forms a pair of congruent triangles. So we've got that floating in our head. We've gotten this far. So now what we're going to do is we're going to look at the proof part. We're going to make it be the last statement in our proof. So we're going to leave some space in here in case we need it. We could leave more space, less space. We really don't know how much space we're going to need. And so we're just going to put it down here. AC is equal to BD, and we need a reason for that. So our whole job in this proof becomes to have a way to say that AC is equal to BD, a reason. And whatever reason we prove that by, we have to make the whole statement line up to say that, just like a roadmap, taking us from what we were given down to what we're trying to prove. Now, so we think, well, how could I prove that 2 segments are equal? And so we're going to go through the entire list of ways to prove it. But we're going to use the given, the diagram, and the statements we've already created to try to eliminate as many ways as possible and hope that one specific way jumps out. Now, we might start saying, okay, a midpoint gives us 2 equal segments, or a bisector gives us 2 equal segments, or What else gives us two equal segments? Opposite sides of a parallelogram are equal. That's it. And you go, oh, we already got a parallelogram. Opposite sides of a parallelogram are equal. So you go through the list of things that you know that give you two equal segments, and then one's going to be obvious from the proof. It must be that. We've already concluded this thing's a parallelogram, so we could say that those are equal because opposite sides of a parallelogram are equal. Let's say, wait, that looks like we got it. Well, how do we make sure that we have all of the statements we need and all of the reasons are right and it's in the order that we need it to be in? Well, what I said to do is check your statements and reasons from the bottom up. So we're going to start doing that. We're going to try to see what statements are needed to justify that final reason. Opposite sides of a parallelogram are equal. Well, if I'm going to say opposite sides of a parallelogram are equal, I need a statement that says the sides are equal. There it is. But I also need to know that it's a parallelogram. Well, there's the statement that says it's a parallelogram. So to make this reason, it takes these two statements. I have the statements needed to justify that reason, so we can say that this reason is justified and its statement is justified along with it. So we go to the next needed statement. The next needed statement. The next needed statement was this one. And so we need to see what statements it takes to justify that reason and if they exist. If not, we need more information. It says both pairs of opposite angles are equal. Do we have both pairs of opposite angles are equal? C and B, yes. A and D, yes. This reason needed this statement to say that it's a parallelogram, and it needed these statements that say, yes, those angles are equal. So we need these three statements to justify that reason. That reason is justified, and once it's justified, then its statement is justified along with it. And so this is good stuff here. We go to the next needed statement. This statement was needed to prove it was a parallelogram because opposite sides are equal. Its reason is given. We check to see if it's in the given, and it is. So that reason is justified in that one single statement. There's no needed statements to go with that, so that's justified. We go to the next needed statement, and we look at its reason given. We check, is it in the given? Yes. So this reason is justified because its statement was in the given. That justifies that statement and reason. All of a sudden, every single statement and reason are justified. And so this must be the correct information in the correct order. So this would become statement 1, reason 1, statement 2, reason 2, statement 3, reason 3, statement 4, reason 4, and you would simply shift these to the statements and these to the corresponding reasons. Any questions on that proof? Okay. So in doing proofs, we have a process we're learning, but we also have to know our stuff. We have to be able to quote the geometry book, obviously, as we said at the beginning of the year. So it's important that you keep studying in the rounds. In other words, when you're in chapter 1, you study chapter unit 1, 1, 1, 2, 1, 3, 1, 4. You get to 1, 5, you study 1 through 5. You get to 1, 6, you study 1 through 6. You get to chapter 2, you study chapter 1 and 2. You get to chapter 4, you study 1, 2, 3, and 4. So that you continually know the entire text. Okay? Here's a proof where we're only giving reasons. If we're only giving reasons, we're going to create a note section. We're still going to take what we're given, mark it in the diagram, write statements and reasons derived from the markings in the note section. So we'd say, okay, it gives me that angle 1 is equal to angle 4. I'm going to mark that angle 1 is equal to angle 4. And I'm going to write statements and reasons derived from the markings in the note section. Now I'm going to go ahead and say angle 1 equal angle 4 given, but I want to think, is there anything I can conclude quickly knowing that those are equal? Well, we can, because those are alternated interior angles are equal. And if alternated interior angles are equal, then the lines that form them are parallel, so I can quickly conclude that EI is parallel to AO. EI is parallel to AO. And that's because alternate interior angles are equal. I'm going to go to the next given statement. It says angle 2 is equal to angle 3. So we're going to mark that angle 2 is equal to angle 3. And we're going to write down that because that's what we marked in the diagram. And we're going to put given, but we're going to think, is there anything I can quickly conclude because those are equal? Yes, they are alternate interior angles. So therefore, I can conclude that the lines that form them are parallel. So I can conclude that AE is parallel to IO. AE is parallel to IO because alternate interior angles are equal. And then I go, well, I know that's a parallelogram now because both pairs of opposite sides are parallel. So I can quickly conclude that AEIO is a parallelogram because both pairs of opposite sides are parallel, which is the definition of a parallelogram. And then I can say, well, if it's a parallelogram, then it has these properties. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. Both pairs of opposite angles are equal. The diagonals bisect each other. Each diagonal forms a pair of congruent triangles. So we have all those things going on in our head. So we know at the end of this, we've got all of those parallelogram statements that we could make, and we're not going to put those in the note section. We're just going to remember it. So we took what we were given, we marked it in the diagram, we wrote statements and reasons derived from the markings in the note section. Now we're going to go to give reasons. When you give a reason, you look first at the given, second at the diagram, and third at the statements above. So angle 1 equal angle 4. We look in the given and it's there, so we put given. It also said angle 2 is equal to angle 3. So 1 equal 4 and 2 equal 3. 1 equal 4, 2 equal 3, given. The next statement says that EI is parallel to AO and EA is parallel to IO. And we look first in the given, but it's not there. So we go second to the diagram and we can see it marked with arrows. Now we marked that. If we mark that, then the reason is going to be down here in the note section if you've done what I've taught you to do properly. And there's the reason alternate interior angles are equal. Notice that sometimes when two statements have the same reason, we may join those two statements in a proof. And then it says the next statement, EIOU is a parallelogram. We look in the given and we don't see it. We go to the diagram. It doesn't say it is a parallelogram, but there it is in the note section. It's a parallelogram by definition. Now, we could have seen in the picture that we had both pairs of opposite sides parallel, and so there was a good possibility that we noticed that already, and we put the reason for it being a parallelogram in the note section. Now, the next thing is what we're trying to prove, and do not put prove right here. prove is not a reason. This is what we're trying to prove, and we need a reason that's a theorem. Now, we're trying to prove that AE is equal to IO. AE is equal to IO. Well, that's opposite sides, and this is a parallelogram, and that's part of all this stuff that we decided not to write down. If it's a parallelogram, then we have 6 properties. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. That's it. And so that's our reason. Both pairs, and I'm abbreviating, of opposite sides are equal. Any questions on that? Okay. Hope you're getting better and better and better and better at proofs. We keep going over them. You can't help but get better, but it is your responsibility to learn the process and your responsibility to do the memory work that it takes to be able to do a proof. It's not going to hit you what theorem to use if the theorem is not in your head to start with. It's not going to come out if it's not in there, okay? All right. Draw and label the following. Draw and label the following. And I think what I was going to say, what I may do is go back to that picture where I can pull in a ruler and all. But that takes a lot of work. I think I'll just explain it again with a drawing. What you would do then is you would lay your ruler down, and you're going to have 1 inch, and then you know that a 1/2 inch would be halfway there, and a 1/4 would be 1/2 of a 1/2, so that would make 4ths, and then 1/8 would be smaller than that, and I'm getting a little visually smaller, but you start with a hole when you go, well, there's a 1/2. So 1 3/4, if this is 2, I may just go ahead and pull that in. Let me go ahead and pull that in, and I'll do this accurately one more time. Bear with me. I'm going to pause this, and so you don't have to watch all of this. I'm going to snapshot it and put it in a smartboard file that's already got a compass and a ruler on it. Okay, we're back. I've got my picture up a little bit high there. We'll bring it back down. So we've got rectangle EFXH. We're trying to construct this. It says EF is 1.4 centimeters. FX is 1 3/4 inches. So we're going to start out with FX. Now, again, like I was trying to show you, and we'll go to here. From here to here is 1 inch. Now, if that's an inch, then this mark then would have to represent a 1/2 inch. Half of that would have to represent a 1/4 inch, so those would be 4ths. Half of that would have to represent an 1/8, and half of that would have to represent 1/16. So we went from 1 whole to 1/2 to 1/4 to 1/8 to 1/16. To half it, you double the denominator. See? Okay. So according to this ruler, which is making it a little bit bigger looking so we can deal with it, we would go from here, 1 1/4, 1/2, 3/4 is there. Okay. Okay, and then it's a rectangle, so we want a 90-degree angle, so we would grab our protractor. We would set the vertex, the hole in the protractor here on the edge. We're going to line this up on this edge. We want it to be 90 degrees, so we will get a marker and we will mark 90. And then we would remove the protractor, set a straight edge on it. This is almost easier to do by just hand drawing it. I can get there faster. And my line moved on me just a little bit because you can see my mark stayed on there. It's kind of difficult here. It's pretty amazing technology. So then we would draw straight up, which would be 90. But then the main reason I wanted to show you this, I wanted to show you on the ruler that 1/4 of an inch. Let's go back and make this a metric so I can talk about that just a second on a ruler that you can see. It says 1.4 centimeters. Let's talk about that. These guys right here are centi. And I can't, it's not letting me write on the ruler itself. And so the 1, 2, 3, 4 are centimeters. This 1, 2, 3, there we go. I couldn't write. I'm not sure what's happening here. That 0, 1, there we go, 2, 3, those are centimeters. These little bitty marks in here, those little bitty marks are millimeters, and it takes 10 millimeters to make a centimeter. So 1.4 centimeters would be to the 1, and then 4 little bitty marks past the 1, okay? All right, we're going to go back to the original picture. So we're going to freehand this thing. We'll do 1 3/4 inches. Again, I expect it to be accurate. You'll get your ruler measure. You would get your protractor, and you would find what 90 is. You would go up 1.4 centimeters. You'd make it 90 again and go 1 3/4 inches. And then you would join those. And so we would have F X at 1 3/4 inches. It's EFX H, so this would be E, and there's your F, and there's your X, and there's your H. So EF is 1.4, therefore HX would be 1.4. FX, therefore HX is 1.4 centimeters. FX is 1 3/4 inches, and so EH would be 1 3/4 inches. It says angle EFX. EFX is an angle of the rectangle, and so we know that it would be 90 degrees. Any questions on number 56? Number 57, again, I'm just going to freehand it and show you how. It says trapezoid AEIF has a lower base of 4.2 centimeters. Remember, on the centimeter ruler, you would go 1 centimeter, width of a thumbnail, 2 centimeters, 3 centimeters, 4, and then you're going to get 2 of those little bitty marks, right? So you're going to have 4.2 centimeters, which is about the width of 4 thumbnails, which isn't very big. And so there you would have lower base IF at 4.2 centimeters. It says leg AI is 3 centimeters, 4 millimeters, which is equivalent to 3.4 centimeters, right? It says that angle AIF, so A sitting out here somewhere, right? It's out there 3.4 centimeters away, but there's a 75-degree angle. Well, how do we do that? Well, what we're going to do is we're going to get our protractor, our compass, excuse me, and we're going to open it up to 3.4 centimeters. we're going to put the point here and the pencil here, and we're going to make an arc that's 3.4 centimeters away from point I. But then we want to get our angle right. And so we're going to get our protractor and we're going to set it in here. And we're going to measure 75 degrees from here. And we're going to make a mark. And we're going to go from I through the mark to the arc. And we'll have the right length. You could just measure the angle and make your segment too long. And then you could take out that segment. Then you could knock off the end of the segment, or you can do like this and then take out your arc. Now we know that if that's 75, then this has to be 105. So we could do the same thing, measure that 105. We know that because, I'm sorry, I'm trying to build a parallelogram. That angle is 84. So we'd set our protractor here. This would be our 0. We would go from here to 84 degrees. And we would measure 84. We would want to be parallel, so this angle up here is going to have to go with the 75 to make a 180. So let's show what we've got so far. I'm going to backtrack a little. You would start with point I. You would draw I F at 4.2 centimeters. You would measure this angle at 75 degrees. You would measure with an arc, or just measuring this side at 3.4 degrees, or 3.4 centimeters. You could take off the top of that, or you could have made the arc and taken it off. You would measure this angle at 84 degrees. You need the upper base to be parallel to the lower base. For those to be parallel, if I take a look at the top, upper base, lower base, and this leg, then if this is 75, this has to be 105, because if these are parallel, then same sides make a C, and they're supplementary. Same-sided triangles are supplementary. So then we would measure that angle at 105 and go across to where that came through, and that would be our trapezoid. Angle AIE is that 105 that we figured out. Angle AEF, how would we get that? Angle AEF. Well, it makes a C this way with the 84. So 180 minus 84 would be 96 degrees for angle AEF. If those are parallel, which they are, because in a trapezoid, one pair of opposite sides is parallel. That's the definition. Those parallel sides are called the bases. Then if those are parallel, then same side interior angles are supplementary, meaning that the sum of their angles is 180 degrees. Any questions on 56 and 57? Again, I think it's very important to do these problems. These problems make us have to stop and draw and label and scratch things out. Good practice for real life. It's good practice for tax. It's good practice for end of course tests. It's good practice for ACT tests. It makes you have to think about and manipulate these rules and theorems. So my goal as a teacher for my students is that you draw these accurately exact and precise, and you do the measurements and you do the calculations and you figure, And you learn how to use equipment like a compass and a protractor and a ruler. Okay? All right, that concludes chapter 4 for us. We will begin chapter 5 later.